All right, so for this type of situation, like we said, can't use rationalizing, you can't do factoring. So we're looking at a complex fraction. And we have to simplify this down. Something's going to cancel or something's going to simplify. Because right now, if we plug in 0, we're going to have 1 over 3 minus 1 over 3 over 0, which is 0 over 0, indeterminate form. More math is needed. So let's go ahead and try to think through what we could multiply the top and bottom by. Again, I'm a big proponent for multiplying by the GCD. Everybody see that that's what that says up here? GCD. So if I multiply the top, I'm going to multiply by 3 times x plus 3. That's the greatest common denominator. Okay, got that, and I got that. If I multiply together, that's called the GCD. And then the same on the bottom, because I'm really multiplying by 1. Limit as x approaches 0. What's going to happen to the first one? I'm going to end up just getting 3 because the x plus 3 cancels when I distribute. And then undistribute the 3, or to the 1/3, the 3 cancels, and I get x plus 3. Okay, so we got 3x, x plus 3. I just switched these 3 and the x's around just so that it said 3x instead of x times 3. Not a big deal. Let's go ahead and see what happens next. Simplify the numerator like we did before. So that's 3 minus x minus 3. I think I have an idea what's happening next. I'm going to write over here because I'm about to run out of space. The 3 minus 3 goes away, and I get negative x over 3x x plus 3. Now, hopefully you recognize that this isn't as simply canceled out as before, but there's an x here and there's an x here. So this becomes a 1, negative 1 on top. So we can go ahead and plug in 0 and see what happens, because at least we have a value on top. We know we have a value on top. And the value on top is negative 1. So this is negative 1 over, if you plug in 0, you get 9, 3 times 3. So that is what we're approaching on either side. All right, pause the video, try this one on your own. But first, test and see if it is indeterminate form through direct substitution. All right, plugging in 0 over 4, you get 0 over 0. So we have to multiply by the GCD. So that's 5 times x plus 1. 5 times x plus 1. All right, let's go ahead and distribute and see what happens. Limit as x approaches 4 of 5. That's going to be 5, right? Distribute that. That just leaves the 5 minus, and then the x plus 1 is left over. And then in the bottom, it's x minus 4 times 5 times x plus 1. Please don't distribute anything in the bottom. If there's anything you learned today, please don't mess with the bottom, because the top is going to simplify itself. The bottom's where you just kind of look and see and cancel. Okay, so if we distribute, we got 5 minus x minus 1. Leave it alone on the bottom. Leave it alone. Don't do anything with the bottom. All right, and then the top, 5 minus 1 is 4. So we get 4 minus x, x minus 4, 5x plus 1. Limit as x approaches 4. Okay, so I'm seeing something that's similar but not the same. X minus 4 and 4 minus x. Strategy for getting things that look like that to look the way we want it to. First of all, I'm going to erase this and just put it in the same order. At least you can put the x first. And then I notice that this is the same as down below, except for there's like opposite signs, right? Because the x is positive, now it's negative, negative, and then positive. So what that means is the numerator has been multiplied by 4, or sorry, by negative 1. And if we factor that out, super tricky, and do not mess with the bottom, we end up with that. So let's go ahead and write what that would become if we plug in 4. I think we can do that now. So we got negative 1 on top. On the bottom, that's 4 plus 1 is 5, so 25. And just so we know, until we get to those red lines, this is still 0 over 0, 0 over 0. Anytime you plug in anything, substitute in the value of 4, you're going to get 0 of 0 until that cancellation happens. And after that, you're golden. All right, so you're going to have some practice to work on. The closure is right here. So check it out, and I will see you guys tomorrow. Boom.